All right, welcome back to another video. And in this lesson, we're going to go over exponents. So as a refresher, recall that an exponent is just basically a much more simplistic way to express multiplication, right? So let's look at this. 3 times 3 times 3 times 3 times 3. Instead of writing all of those threes, couldn't we just say that this is 3 with an exponent of 5? Or 3 to the 5th power? Yes, we can, right? Um, so, exponents are nothing to be afraid of. We're going to be doing this a lot, and you're going to see that we're going to use this technique, just break them up like that to uh, create exponents for ourselves, numbers with base, we call this right here the base. We call that the exponent right there. So we're going to get really, really acquainted with these in the next few minutes. So let's go ahead and begin. So let me erase this little thing here. So at any point, so let's say they give you a number such as, I don't know, 81. 81 can be broken down. You can keep dividing. What times what would give you 81? 9 times 9, right? And couldn't you break down the two nines? So that'll be 3 times 3 will give you this 9. And the same with this one. So we have 4 threes in total. So basically 3 times 3 times 3 times 3 is 81. So wouldn't that just be 3 to the 4th power? So instead of writing 81, we will write this as 3 to the 4th. Same thing with something like 27. 27 we know is 9 times 3. And then we can also break down the 9. So this is 3 times 3 times 3. So 27 is 3 to the, how many 3's do we have? 3. So that's 3 to the 3rd power. So we're going to get into the habit of breaking these numbers down because they can show up to be large at first, but as long as you can divide it by some number, you'll see how easy this is. So I think we can make up a little example. Let me delete this stuff. Okay, so say for example, they say 3 to the, get my pen, 3 to the x is equal to 3 risen to the, let me think of a good one, 2x plus 1. So ask yourself, do these two expressions on the left and the right, do they have the same base? Yes, we have a 3 here as our base, and we have a 3 here as your base. So once you have the bases equal to one another, you can basically ignore the bases. I hate to say it this way, but this is really what's going on. In mathematics, you want to be able to cross out and cancel things as much as you can, right? So once they have the same base, and you're going to see, you're going to make them have the same bases if they're not the same already. Once they have the same base, you can just cross them out. This is what I do. So what are you left with? You're left with x is equal to 2x plus 1. So way less complicated than the beginning, right? So now we have a simple algebraic equation that we can solve. So, bring your x's over to your right. Anything that does not have an x, you bring it to your left. You're going to subtract x from both sides. And while we're at it, let's go ahead and bring this 1 over to the left side by subtracting it. So you're left with -1 is equal to 2x minus x, which is just x. So after all of that, we get x is equal to -1. So remember your original was 3. Yeah, let's separate this. Remember your original is 3 risen to the x is equal to 3 risen to the 2x plus 1. Another thing of note, I want you to imagine that this 2x plus 1 is wrapped up in parentheses, okay? And technically that one too. I don't want you to think that it's all on the same line. Remember, an exponent is like in its own separate realm. It's up there. It's slightly above the 3, right? So, yeah, you can pretend that there's parentheses wrapped around it, which they are technically. Okay, so based on the answer we just got here, x should be -1. These two should be equal to one another, right? So 3 risen to the -1, we're just plugging in -1, is equal to 3 risen to the 2 times -1 plus 1. And they both should be the same. So 3 to the -1, we're just going to leave it as 3 to the -1 for now. Is equal to 2 times -1 is -2. Then we have plus 1 in the exponent. So we have 3 to the -1 is equal to 3 risen to the -2 plus 1 is -1. So look, they are exactly the same. So we know this answer is right. And remember, if you put the number first, it's okay. It's okay. -1 is equal to x, so x is equal to -1. It's the same thing. So we got this question right. And you may be asking yourself, okay, what is 3 to the -1 power anyway? It's good that we came for this. We got the answer. We're going to move on to the next one. But what is 3 to the -1? How do we even evaluate a negative exponent? Well, first, you can't evaluate it the way it is right now. We're going to have to change this up just a little bit. Just bear with me here. Technically, this is over 1, right? All numbers are over 1. All numbers are being multiplied by 1. Whenever you have a negative exponent, and this is just, I'm going to make it really simplistic. Basically, bring whatever has the negative exponent on down. So that includes this guy here, right? Just bring it down. It becomes 3 to the +1. And because you brought this thing down, there's a 1 on top. So it's very simplistic what we just did. And anything risen to the first power is just that number, right? So this is basically 1/3. This is the simplistic approach. Perhaps I'll go in detail when it's necessary later on. But that's the idea. Whenever you have a number risen to a negative exponent, you basically, I hate to say, you flip it and change it to a positive exponent. Even if it was something other than 1, like 3 to the -2, right? That's just going to be 1 over 3 to the +2. So this is just a little precursor to solving these things. So I have another example. They see you guys sending me problems. So let's say we have 4 risen to the, where is it? Let me see. Give me 1 second. All right, here's one. 4 risen to the -6x is equal to 16 risen to the 2 minus 2x. So both of these, the bases are not the same, but we can make them the same. And I'm going to do 2 different approaches to this, right? So go ahead and take a look at 16. Could you express the number 16 with a base of 4? Well, yeah. Isn't that just 4 squared? Wouldn't that give you a 16? Yes, it is. So that's one way you can go about it. But let's say you wasn't too savvy with the numbers and you don't have that much confidence, right? You can go ahead and break down the 4 and break down the 16. So here's what I mean. What times what would give you 4? 2 times 2, we know that. So we can say this is 2 risen to the 2nd power. What about the 16? If you break down the 16, what would you get? That'll be, you can say this is 8 times 2. This is 4 times 2. This is 2 times 2. So how many 2's is that? 1, 2, 3, 4. This is 2 times 2 times 2 times 2. So we can say that that's 2 to the 4th power, which is 16. So check it out. They both have the same base. They both have a base of 2. And that's really your main goal. You want to make them have the same base. So I'm going to show you what happens when you have, you express the numbers as, a base 2, or I'm also going to show you what happens when you just change one of them. In hindsight, if you change just one of them, That'll save you a little bit of work. So I'm going to erase these guys here, and we're going to make a little note right up top. Let's change them both into base 2. So we know 4 is just 2 risen to the second power, and 16 is 2 risen to the fourth power, right? Let's keep that in mind. So what I want to do, I want to change this guy into a base of 2. So wouldn't that just be 2 squared? Oh, still white. Back to orange. Wouldn't that just be 2 squared? Now, didn't we already have an exponent sitting up there? Yes, we did. We created our own exponent, which is this 2 here. There was already an exponent up there. So what you do is multiply them, okay? You just put it right next to it. Same thing here. Let's express 16 as a base of 2. So this is 2 to the fourth power. So this is 2 to the fourth power. Now, what was already up there? Remember, I said we're going to put this in parentheses. So 2 minus 2x was already up there. So you want to just put it in the parentheses and multiply with the new exponent that we just created. Remember, we created this 4, right? So if you create your own exponent, make sure you multiply by the exponent that's already up there. And now take a look. They both have the same base. So now we are free to just cross them out. And now we're just left with the exponents equal to each other. So we have 2 times negative 6x is equal to 4 times 2 minus 2x. Go ahead and distribute. 2 times negative 6x is negative 12x. Go ahead and distribute this. This is going to be 4 times 2, which is 8. 4 times negative 2x is negative 8x. And now you know the deal. If it has an x, you want to bring it to one side. If it doesn't have an x, you want to bring it to the other. Let's go ahead and move this 8x over to the left-hand side by adding it. Cross them out. Negative 12 plus 8 is going to be negative, and you subtract them. So we get 4x is equal to 8. Divide both sides by negative 4. You're going to get x is equal to negative 2. Now, I'm confident that we did this correctly, but you always want to make sure that you plug in your solution to make sure that you know that you got it right. So let's go ahead and plug negative 2 mentally. Negative 6 times negative 2 is positive 12, right? So we better get a positive 12 over here. Oh, wait. Yeah, it's a base of 4. Yeah, let's not do it mentally. Let's plug negative 2 in here. You get 4 to the positive 12 is equal to, and we're going to do the same thing over here. Plug in negative 2. That's negative 2 times negative 2, which is positive 4. Then we have 4 plus 2 is 6. That's a pretty large number, right? Listen, if you put this in the calculator, it's going to be correct. Which brings me to my next point. You can go ahead and switch. You can change the basis of just one of them. So let's go ahead and take it back. It works in the calculator. Take my word for it, and I'll show you in a much more simplistic way. So let's say you didn't want to change the base of both of them, but you just wanted to change the base of one of them. So I'm gonna go ahead and this is still a 4. Let's erase this stuff. All right, this is still a 4. Okay, so couldn't I just express 16 as a base of 4? Couldn't I just say that 16 is also equal to 4 squared? Why not? And it saves me the trouble of changing this one because this is already a 4. So I'm going to say this is 4 risen to the negative 6x is equal to, now we said we're going to change this portion here into 4 squared, right? So let's do it. This is 4 squared now. Wasn't there already an exponent up there? Yes. So this is 2 minus 2x. And you're going to see we're going to get the same solution. So they both have the same base. That's good for us. We're just going to cross them out. You get negative 6x is equal to, distribute, 4 minus 4x. We're going to go ahead and move this 4x over to the left-hand side by adding it. Cross them out. You're left with negative 2x is equal to 4. Divide both sides by negative 2. Check it out. We get x is equal to negative 2 again. So we did it 2 different ways and got the same solution. So safe to say, this is definitely the solution. And that's all there is to it for now. And as you know, they can make it more complicated by putting a quadratic or something in there. I'm gonna do some more examples in a separate video. All right, thank you for watching.